Okay? First, I am giving my introduction. Myself, Professor U.V. Ranade, M.Tech Structures at IIT Mumbai. I am going to teach you applied mechanics in different lectures. Today's first lecture I am giving you on first topic, that is force, system of forces, resultant of forces, and so on in due course. First, force. F equal to M into A. In this, M is mass, its unit is kg. A is acceleration. Acceleration is rate of change of velocity. Its unit is meter per second square. So, unit of F is Newton, and on the right hand side it is kg, unit of mass, and into meter per second square. So when we want to give unit for force, its unit is Newton. Now, system of forces. Now there are number of forces acting at a point. Before that, I am going to tell you that if any force is to be represented, that means any quantity is to be represented like that, force also is required to be represented. Now how force is to be represented? Any force acting is to be represented in magnitude, direction, and position or point of application. So its magnitude is to be given. Generally, magnitude of force Newton. Direction. Suppose force is acting like this. It is making angle theta with point O and x-axis. Then direction is force acting at an angle theta about x-axis or with x-axis. Actually, these quantities will be given in examples. For example, magnitude. We have said Newton, but 10 Newton, 5 Newton, 7 Newton, like that. Direction, theta. Theta means 20 degrees, 30 degrees, and so on. This is for example or understanding. Now, position. Now here, force is acting at point O. So this is position or this is point of application. So if any force is required to be represented, it is to be stated what is its magnitude, what is its direction, and what is its position or location. Cosine. After this, system of forces. Now what is meant by system of forces? Actually, there are number of forces acting. Now how these different system of forces, that I will explain. Now one is coplanar, means all forces acting on one plane. For example, this is plane, all forces are acting. Now after coplanar, I will again explain the under coplanar how many different system of forces. And second is non-coplanar, means not in one plane, in space. For example, this is the point. Are you getting? This force is acting here. Another force is acting in this plane. Another force acting in downward direction. That I will in due course explain. Now coplanar. Coplanar parallel or forces parallel. Some forces opposite. These are parallel. Coplanar concurrent means this is x and y axis. Coplanar concurrent or forces acting at only may be towards point or away and so on. Coplanar non-concurrent. And coplanar non-concurrent. In non-concurrent, see, it is like this. Here all forces are passing through same point, O point. But coplanar non-concurrent, they are not passing through same point. Some force acting here, some force acting here, some force acting here like this. Each point of all forces are passing through the same point? No. All forces are not passing through the same point. Therefore, they are called as coplanar. They are in same plane but non-concurrent. They are not concurrent. If you consider these two forces, it is at this point. But if you consider this point, this force, again this point. Suppose if you consider this force, this is acting or passing through other point. So these are coplanar. These are coplanar, but these are non-concurrent. Once again, coplanar, parallel. Parallel means all are parallel to each other. Now in parallel also, to explain you, all forces parallel are not in one, not necessarily in one direction, like this. These are passing like this, and this is upwards. This can be again downwards. This can be again, but all are parallel. One second. Now, concurrent. All are passing through same point. This is to refresh or once again remember or understand you. Non-concurrent. X and y axis is there, point is O, but non-concurrent. See the figure. This is force, this is force, this is force, this is force. There are number of forces, but is point of application of all forces same? No. All forces are not passing through the same point. Now consider coplanar, non-coplanar or space forces. Now these are similar forces. How? See. For example, this is little bit difficult to understand, but actually in practice or in your syllabus or in your problems, this non-coplanar or space forces problems are not there in your syllabus, but for theory purpose I am explaining. Suppose this is the point, or suppose this is the point. Now one force, now all forces are passing through same point, that is this point. One force is like this, one force is like this, one force is again not like this but somewhere here. In space, if you consider space, consider one point, one force like this, one force like this, one force like this, one force like this. Again, these forces also may not necessarily be acting towards point. Some can be towards point, some can be away from point. So these are non-coplanar or space forces. Now in again non-coplanar, there can be parallel forces. Can you imagine? Suppose this is the point and this is the space. Now one force is like this. Now in space only, in same direction, force is acting, and that also may not be necessarily towards or downwards but parallel, but not in one plane. Are you getting? So there can be two forces, three forces and so on. So this is coplanar, once again, coplanar, parallel, coplanar, concurrent, coplanar, non-concurrent. In non-coplanar, parallel, concurrent. In non-coplanar also can become concurrent, just now I said. Consider point or process passing through or away from the point, but in space, not in one plane, and parallel. So these are system of forces. Now next, resultant. Now normally you have problem, number of forces are given and it is asked that you find the resultant of that system of forces. So how to find the resultant? Before that, what is resultant? Resultant is a single force. So resultant is a single force that is having same effect as that of number of forces. Whatever is considered, suppose this is a body and there are different forces acting. Anyway, either coplanar, concurrent or non-concurrent, whatever it is. Now, suppose this is stone. Consider a stone or any body. Now, suppose different forces are acting. After different forces, consider F1, F2 like that. Now, its effect on the body will be there. What will be the effect? We see. Suppose a body is there. Or it will move, or it will have some effect. It may go in this direction, it will go in this, or it will have movement. It will have movement. Sometimes it will have rotation or whatever. So this is the effect of system of forces. But what is the resultant? Resultant is not different forces, but resultant is a single force. It is called as R. R is resultant. And what is resultant? It will make same effect as that of system of forces. Whatever is the system of forces acting and making effect on the body, same effect will be made by a single force, and that single force is called as resultant. Now this resultant, as I have previously said, also is to be represented in magnitude, direction and position. That is, magnitude means, suppose to give example, 10 Newton. Direction, making angle with x-axis or horizontal, suppose 25 degrees. And position, what is position? To give example, if all forces are in one plane and passing through the point O, the point of application or the location is O. So resultant is a single effect that makes, which is making due to number of forces acting. So you can find resultant. Now how to find resultant? To find resultant or object to find resultant. Now instead of going in complication, first I will take simple example. Suppose 10 Newton force is acting, 2 Newton force is acting, 5 Newton is force acting. Now I want resultant. It is very easy. Resultant is 10 in this direction plus 5, 15. This is in opposite, minus 13 Newton. Now it is acting on one same point, so no question of magnitude is there and location etc. are in same point. Another example. I am going from simple to complicated. Suppose consider parallel forces. Suppose 15 Newton, 10 Newton, 12 Newton, 7 Newton. This is downward, this is downward, this is upward. All are parallel, but downward, downward, upward, and downward. Now to find single force or result, what will it be? 15 plus 10, 25, plus 7, 32. Are you getting? 30. Now 32 in downward, and what is this? Minus 12 equal to 20. Now what is its direction? These are downwards, so this is downward. And these are parallel. Next, little bit complicated. Say, coplanar and concurrent. Consider x-axis. Consider y-axis. Now first I will explain in f theta like this. Then I will take one example. Suppose f1, simple cases, f2, f3, f4, or f5, f6 like that. Process is same. Now before that, in example, you are given magnitude of force, also direction of force. Direction of force is every force making angle theta with x-axis. So let F1 makes angle theta 1. Let F2 makes angle theta 2. Let F3 makes angle theta 3. And so on. If 1, 2, 3, 4, see, forces are F1, F2, F3, so on. And what are the angles? Angles are theta 1, theta 2, theta 3, so on. So again, all forces are concurrent. All forces are F1, F2, F3, etc. And all are making angles theta 1, theta 2, theta 3, etc. with x-axis. This is the data. This they are given. And what is the question? Or what we have to find? We have to find resultant. Now, for that, small theory is required to be understood. It is like this. It is called as resolution of force. If F is the angle, if F is the force, theta is the angle, then we have to resolve every force along x-axis, along y-axis. We are making all forces by resolution of force theory all along x-axis, all along y-axis. So how that? Theta is angle. So fx. If fx is the resolved part, it is called as resolved part. Resolved part of f along x. So fx is given by f cos theta. Whereas if fy is the resolved part in y direction or vertical direction, this fy is f sin theta. This is called as resolution of force. Why this is made? That you will understand while solving the problem. Whatever are the forces you have to resolve along x.
चार्ज समतल